Our planet, a tiny fragile sphere, drifts through the vastness of space. Its lifeblood, the energy that fuels every leaf, every creature, and every civilization comes from a single magnificent source: the Sun. This star is a colossal nuclear fusion reactor, located 93 million miles away. It relentlessly bombards our world with photons, those tiny packets of energy, every leaf, every creature, every civilization. Some places on Earth receive this stellar gift more generously than others. Imagine a place so vast, so perfectly positioned, that it basks in this cosmic energy firehose almost year-round. That place is the continent of Africa. Its immense landmass straddles the equator, receiving some of the highest levels of solar irradiation on the globe. This abundance of sunlight is not just a geographical curiosity, it is a profound opportunity. For millennia, humanity has relied on burning the compressed remains of ancient life: coal, oil, and gas. But this has come at a great cost to our planet's delicate climate. Now, we stand at a crossroads, looking to the sky for a cleaner, more sustainable answer. Africa, with its sprawling deserts and sun-drenched savannas, holds a key to this future. The very energy that has shaped its landscapes for eons could soon power not only its own vibrant growth but potentially the entire world. It's a cosmic inheritance of staggering proportions, waiting to be claimed. Think about the numbers for a moment. The Sahara Desert alone, a vast sea of sand covering over 3.6 million square miles, receives enough solar energy in a single year to power the entire globe many times over. If we could capture just a tiny fraction of 1% of the sunlight falling on this one desert, we could satisfy all of humanity's energy needs. This isn't science fiction, it is a statement of physical reality. The potential is written in the very fabric of the cosmos, delivered to Africa's doorstep every single day, from sunrise to sunset. The question is no longer if we can harness this power, but how we will choose to do so. So, how do we perform this modern alchemy? How do we transform pure sunlight into the electricity that powers our homes and cities? The answer lies in a remarkable piece of technology called a photovoltaic cell, the heart of every solar panel. The principle behind it is called the photovoltaic effect, a phenomenon first observed in the 19th century. It's an elegant dance between light and matter. Imagine a solar cell as a specially prepared sandwich usually made of silicon, a very common element found in sand. This silicon is doped. Tiny amounts of other elements are added to create two distinct layers. One layer is engineered to have a surplus of electrons, giving it a negative charge. The other layer is designed to have a deficit of electrons, or holes, giving it a positive charge. Where these two layers meet, an electric field is created, acting like a one-way street for electrons. Now enter the hero of our story, the photon, that little packet of sunlight we talked about. When a photon with enough energy strikes the solar cell, it can knock an electron loose from its atom. This newly freed electron is then swept across that electric field from the negative side to the positive side. This movement of electrons is, by its very definition, an electric current. This flow is the genesis of solar power. A single photovoltaic cell produces only a small amount of electricity, but when you link many of them together, you create a solar panel. And when you connect many solar panels, you create a solar array, capable of generating significant amounts of power. It is a beautifully simple and direct process. This solar revolution is not a far-off future. It is already beginning to unfold across the African continent. From the shores of the Atlantic to the Red Sea, nations are harnessing their solar birthright, creating beacons of progress that illuminate the path forward. Take Morocco, for example. On the edge of the Sahara Desert lies the Noor Ouarzazate Solar Complex, one of the largest concentrated solar power plants in the world. It's a breathtaking sight, a sea of curved mirrors, all meticulously tracking the sun's journey across the sky. These mirrors focus the sunlight onto a central tower, heating a fluid to create steam, which then drives turbines to generate electricity, even after the sun has set. Further south in Kenya, we see a different but equally inspiring story. The country is a leader in integrating solar power into its national grid, and crucially, in bringing power to remote communities. Projects like the Garissa Solar Power Plant, the largest in East and Central Africa, provide clean energy to tens of thousands of homes. But the revolution is also happening on a smaller scale. Individual solar home systems are transforming lives in rural villages that have never been connected to a central power grid. families can now have light in the evenings for children to study, power for charging phones to stay connected, and energy to run small businesses. Let's travel west to Senegal, a nation that has made remarkable strides in its commitment to renewable energy. The country has rapidly built several large-scale solar farms, significantly increasing the share of renewables in its energy mix and reducing its reliance on expensive imported fossil fuels. Similarly, in Egypt, the Benban Solar Park is a colossal achievement. Located in the country's western desert, it is a sprawling complex of individual solar plants that, when fully operational, will be one of the largest on Earth. This single project prevents millions of tons of carbon dioxide emissions every year, a massive contribution to our planet's health. These examples are just the beginning. They are writing the first chapters of Africa's solar story, a story that promises to reshape the continent and the world. The vision for Africa's solar future extends far beyond its own shores. Imagine just for a moment a scenario where the continent doesn't just power itself, but becomes a green energy exporter to the world. This is not a flight of fantasy, it is a tangible, ambitious goal grounded in physics and economics. The sheer scale of solar energy available particularly in North Africa far exceeds the continent's own needs. The key lies in high-voltage direct current HVDC transmission lines, superhighways for electricity. HVDC can move vast amounts across thousands of miles, even under the sea with low losses. Massive solar farms in the sun-drenched Sahara channeled into HVDC cables running north under the Mediterranean Sea, plugging into the European grid, delivering clean, reliable energy 24/7. The impact of this solar revolution goes far deeper than just electrons moving through a wire. Its most profound effects will be felt in the daily lives of hundreds of millions of people. For the more than 600 million Africans who currently live without access to electricity, solar power represents a gateway to modernity. It means light to read by, refrigeration to preserve food and medicine, power to connect to the digital world. This energy transformation is also a powerful engine for job creation. Building and maintaining a continental-scale solar infrastructure will require a vast and skilled workforce. We will need engineers to design the solar farms, technicians to install the panels, electricians to connect them to the grid, data scientists to optimize their performance. Local manufacturing of solar panels, batteries, other components could create entire new industries. And then, there is the benefit to our shared home, planet Earth. Every kilowatt hour from a solar panel replaces one that would come from burning coal, oil, gas. A full-scale solar boom in Africa would be one of the single most significant contributions to the global fight against climate change. By harnessing its sun, Africa would not only be lifting its own people, but also helping to safeguard the future for all of humanity. Of course, a transformation of this magnitude is not without its challenges. The path to Africa's solar future is paved with obstacles that require cleverness, collaboration, commitment. One of the most significant hurdles is the initial cost. While the price of solar panels has plummeted dramatically over the past decade, building large-scale solar farms and the vast transmission infrastructure needed to support them still requires immense upfront investment. Mobilizing this capital is a critical first step, from public sources, from private sources. Another challenge lies in technology and infrastructure. Advanced energy storage solutions are required. Large-scale batteries to store solar power generated during the day for use at night or on cloudy days. Africa's existing electricity grids in many regions are underdeveloped, and will need significant upgrades to handle the influx of variable renewable energy. This is not just about generating power, it's about building the smart, resilient grid systems needed to manage and distribute it effectively. Yet for every challenge, human ingenuity is already crafting a solution. To tackle costs, innovative financing mechanisms like green bonds. To solve the storage problem, battery technology is advancing at a breathtaking pace, becoming cheaper and more powerful every year. To upgrade the grids, smart grid technologies, decentralized microgrids offer flexible and resilient alternatives to traditional centralized power systems. We stand at a remarkable moment in human history. We have, for the first time, the technology and the knowledge to power our entire civilization with the clean and inexhaustible energy of a star. And at the heart of this new era lies the African continent. The facts are clear and compelling. Africa has the highest solar potential in the world, with an average of 300 days of bright sunlight per year across much of the continent. The Sahara Desert alone receives solar energy equivalent to over 7,000 times Europe's total annual electricity consumption. These are not just numbers, they are a declaration of potential. The journey has already begun. The cost of solar photovoltaic technology has fallen by over 90% in the last decade, making it the cheapest source of new electricity in many parts of Africa. This economic reality, combined with the urgent need to combat climate change and provide energy access for all, has created a perfect storm of opportunity. This is a future filled with hope. It is a future where new industries, powered by cheap, abundant sunshine, exporting its clean energy to power the world. The dawn is breaking on a new solar age and its sun is rising over Africa.